42. Water gas, a mixture of H2 and CO, is an important industrial fuel produced by the reaction of steam with red-hot coke, essentially pure carbon. Then we have letter E. What will happen to the concentration of each reactant and product at equilibrium if the temperature of the system is increased? Okay, so we did have our balanced equation. Finally, we're going to use this delta H value. You only care about this delta H value when they're talking about temperature. Now, the only thing that I care about is where the heat is lying. Is the heat on the reactant side or the product side? That comes from the delta H value. I don't care about what the number is. All I care about is whether it's a positive or a negative. And since this number is positive, remember when we did enthalpy, which is delta H, a positive delta H is endothermic. And remember, endothermic means that you're absorbing heat energy. You're not releasing it. So when you're endothermic, the heat is always going to be on the reactant side. So I'm just going to say plus heat on this side. And maybe I will highlight it just to draw my attention to it. And then once I do that, I could care less about this number. I don't have to look at this ever again. I have all the information I need right here. Okay, now let's keep going. So what happens when the temperature increases? Well, if you increase the temp, it's going to get too hot, right? You're raising the temperature, too hot. And if something is too hot, you don't want to be close to it. The chemical equilibrium, you're going to shift away from the heat. Literally, the word heat. Spot out the word heat. That's why I like to put the heat in the equation. If you're going away from the heat, right, I would start on the reactant side and I would go away. I wouldn't want to go towards the heat if the temperature keeps increasing. So in this case, I'm going to be going this way. So now once you do that, you can make your arrows. I'm making more products. Now these are both gases. So I would increase the concentration of CO and I would increase the concentration of H2. This is also a gas, and it's the reactant side now, so that would be decreasing. But now here comes the thing, guys. This is a solid. Would the concentration be going down? No, because remember, solids are not allowed in the KQ, the KC, the KP, or any of the Q formulas. So this would have no effect on the concentration. But you might be saying to me, well, wait a minute, Christina. If the reactants are dropping, this has to go down. And you're absolutely correct. There is going to be a decrease here, but it's not the concentration. It's the mass. The mass is going to be dropping, not the concentration of C. And that makes all the difference. But all these other ones are changes in the concentration. So, H2O, that will drop down. CO, the concentration of CO will increase. The concentration of H2 would also increase. And if you want to just say, the concentration of C, there would be no change because it's a solid and it's not aqueous or a gas. And here are your 4 answers. And there you go. So hopefully this helped. Thank you so much for viewing the video. We're done with this part, so number 42 is all done. So hopefully you guys got Le Chatelier's principle, but if not, no worries. It is a kind of a difficult concept, but hang in there, all right? There's more Le Chatelier problems coming up, so you'll get it on the next one, all right? So I will see you all in the next video, all right? Okay, bye-bye.